We are about to begin our first module of Six Sigma. In this module, we would cover the following: origin of Six Sigma, impact of Six Sigma, definition of Six Sigma, introduction to DMAIC phases of Six Sigma, and introduction to mean and variance through an example. Origin of Six Sigma. Bill Smith is the father of Six Sigma. In 1987, after working for nearly 35 years in engineering and quality assurance, he joined Motorola, serving as a vice president and senior quality assurance manager. Bill Smith spent years convincing the higher management at Motorola about his new quality control process, Six Sigma. Over the years, he and Motorola garnered numerous awards and recognition for his vital work to improve profitability in America's manufacturing sector. He was especially proud of his role in Motorola's winning the prestigious Malcolm Baldrige National Quality Award. The Baldrige Award came in 1988. 2 years after Motorola implemented Smith's Six Sigma principles. Jack Welch was told that Six Sigma, the quality program pioneer by Motorola, could have a profound effect on GE quality. Although skeptical at first, the GE chairman initiated a huge campaign in the GE way, a way that had never been done before, to infuse quality in every corner of the company. Welch called Six Sigma the most difficult stretched goal GE had ever undertaken. Within 4 years, we want to be not just better in quality, but a company 10,000 times better than its competitors, he announced. We want to change the competitive landscape by being not just better than our competitors, but by taking quality to a whole new level. We want to make our quality so special, so valuable to our customers, so important to their success, that our products become the only real valued choice. Welch made an official announcement launching the Quality Initiative at GE's annual gathering of 500 top managers in January 1996. He sets itself a goal of becoming a Six Sigma quality company, producing nearly defect-free products, services, and transaction by the year 2000. What is Six Sigma? Six Sigma has various meanings depending on the context. First, Six Sigma is a measurement system. It is the statistical measure of variation in a process. In statistics, sigma is a symbol of a standard deviation, which is a measure of consistency. Second, Six Sigma is also a problem-solving methodology that can be applied to any process to eliminate the root causes of defects and cost. Third, Six Sigma is a disciplined, data-driven approach towards process, change, and improvement. The term sigma is used to designate the distribution or spread about the mean or average of any process or procedure. Spread or variation is the basis of Six Sigma. It is defined as the fluctuation in the output of a process. Any process improvement should reduce variation so that the process can better meet expectations of both internal and external customers. For a business process, the sigma capability is a matrix that indicates how well that process is performing. The most accurate measure for quantifying variation is standard deviation. Sigma is the symbol for standard deviation. Impact of Six Sigma. If we plot the values for a process, and we have a large number of values, we will likely find that the distribution of values forms a kind of bell-shaped curve, high in the middle and tapering on both sides. This distribution pattern is considered normal. A normal curve can be described in terms of two parameters, its mean and its standard deviation, or sigma. 68% of the values lie within one standard deviation of the mean. 99.73% of values lies within the 3 standard deviation of the mean. For example, plus minus 3 sigma, or total of 6 sigma. We would like to highlight certain examples to distinguish between the classical view of quality and the Six Sigma view of quality. In the classical view of quality, a process is considered high quality if 99% of output is good, while in Six Sigma view of quality, a process is considered Six Sigma compliant only if 99.99966% of output is good. To put this in perspective with 99% quality, if there would be 5,000 incorrect surgical operations per week with Six Sigma capabilities, there would only be 1.7 incorrect operations per week. Several other examples are also provided to drive the point home. For most corporate, the most important reason for using Six Sigma is financial. So let us start with the gains achieved by some of the companies that have invested in implementing Six Sigma. 1. Motorola saved more than $15 billion in its first 10 years of Six Sigma efforts. 2. GE realized a saving of over $1.5 billion in 1999 alone through Six Sigma. 3. DuPont realized more than $1.6 billion in cost savings in 4 years. 4. Lockheed Martin saved over $64 million in the first 40 Six Sigma projects itself. 5. ABB, Allied Signal, Johnson Controls, and many other organizations have saved significant costs by adopting Six Sigma. Sigma level. Consider an operation at 3 Sigma capability, the baggage handling process of a good airline. For every 10 lax pieces of baggage that the airline handles, there is a problem with more than 66,000 pieces. For every missing baggage, the airline workers have to process a report to locate and deliver the piece, which implies wastage of time and money just to correct the mistake or defect. Average companies tend to operate at 3 Sigma capability. There are several examples of Six Sigma capability. The most common example is that of an airline safety. Traveling by air is the safest way to travel, thanks to achievement of Six Sigma capability. Six Sigma problem-solving approach. Six Sigma follows a unique approach. The first step in Six Sigma is to define the problem. We will learn more on this in the next chapter, which talks of the define phase. The practical problem is then converted into a statistical problem. We will cover this in the following chapter when we discuss the measure and analyze phase. The statistical problem is converted into a statistical solution when we try and improve the process. Finally, the statistical solution is converted into a practical solution when we try and control the process. In Six Sigma problem-solving approach, the team can face 2 major kinds of problem. 1. The process is off target. For example, the output of the process is consistently different from the expectations of the customer. Such a process is termed as an off-target process. The objective of the team in this case is to center the process and bring it on target. 2. The other problem can be that the process is centered. However, the spread or variation in the output is high. Such a process can be classified as unpredictable, and the team has to work towards reducing the spread and bringing the process on target. The overall objective is hence to reduce variation and improve accuracy by ensuring that the output is within the upper and lower specification limit specified by the customer. Six Sigma problem-solving approach differs from that of other popular techniques. The idea in Six Sigma is to focus on the process and not the output. Six Sigma problem-solving approach works on the principle that the output is a symptom or an effect and is actually dependent on various causes. Hence, in order to monitor and control output, it is important to control the problems or the causes. These problems are usually independent of each other and need to be tackled to reduce defects. As per the DMAIC methodology, critical questions to be asked are as follows. In the define phase, the critical question is, how do my customers look at me? In the measure phase, the critical questions are 1. What do you want to improve? 2. What is the best way to measure? 3. Can I trust the output data? In the analyze phase, the critical questions are 1. How good am I today? 2. How good do I need to be? 3. What are the factors that make a difference? In the improve phase, the critical questions are 1. What's at the root of the problem? 2. How can I predict the output? 3. How tight does the control have to be? In the control phase, the critical questions are 1. Can I trust the in-process data? 2. Have I reached my goal? 3. How can I sustain the improvement? The Six Sigma methodology generally consists of the 5 phases. 1. Define. 2. Measure. 3. Analyze. 4. Improve. And 5. Control. In short, these phases are referred to as DMAIC. The purpose of the define phase is to determine the objectives and scope of the project, collect information on processes and customers, and specify deliverables. The purpose of measure phase is to map the process, access the current level of process performance, and validate the measurement systems. The purpose of analyze phase is to evaluate and reduce the variables and identify the vital few factors for process improvements. The purpose of the improve phase is to generate ways to improve the process, test potential improvement, and map the future state of the process. The purpose of the control phases is to determine the ability to control the vital few factors and implement process control systems. Six Sigma jargon. Black Belt or BB is a professional who leads Six Sigma projects on a full-time basis. Typically, a black belt has 4 to 5 weeks of classroom training in methods, statistical tools, and team skills. Green Belt or GB is a professional who leads smaller projects on a part-time basis along with his day-to-day work. Typically, a Green Belt has a week of classroom training in concept and tools. Master Black Belt, or MBB, is a highly experienced and successful black belt who has managed several projects and is an expert in Six Sigma methods and tools. A Master Black Belt is responsible for coaching and training black belts, and for helping the Six Sigma leader and champions keep the initiative on track. The champion is a middle or senior level executive who sponsors the specific Six Sigma projects, ensuring that resources are available and cross-functional issues are resolved. A matrix, or CTQ, is an indicator of a customer that is critical to the quality of the process. A customer is who receives the process output. A customer may be internal or external. Tips. In this chapter, we would have covered the following. 1. Definition of Six Sigma, its problem-solving approach, and linkage between Six Sigma and number of defects. 2. Understanding the financial benefits of Six Sigma and companies which have adopted Six Sigma. 3. Understanding of DMAIC methodology and the critical questions to be asked in each phase. 4. Definition of key terms used in Six Sigma, such as green belt, black belt, master black belt, etc. Assignment. Ajax Logistics delivers container loads for LLC, a Fortune 100 company. You are the logistics manager for LLC. You have experienced delayed deliveries in the past and have shared the same with Ajax. Ajax had promised to improve the service by December. 2 months later, Ajax claims that the service has in fact improved. Ajax provides you with the delivery pattern in October versus December. Compare the two situations using average. What is the percentage improvement? The mean can be calculated as the sum of the delivery cycle time divided by the number of entries. The sum of cycle time in October is 206, and the number of entries is 13. Hence, 206 divided by 13 is the mean, which is 15.8. Mean is also referred to as X-bar. Similarly, calculate mean for December. Standard deviation can be calculated as follows. 1. Calculate X minus X bar. 2. Square the difference between X and X bar. 3. Do these for all entries and calculate the overall sum. 4. Calculate square root of A divided by N, where N is the number of entries. As is evident from the graph, mean has reduced from 15.8 to 11. While it seems like an improvement, actually, LLC is far from happy. This is because the spread of variation has increased. Earlier, variation was 7 days, which has now increased to 9 days. Customer feels the spread and hence is not happy with the results. With this is the end of our introductory module for Six Sigma Green Belt program. Next module we are going to learn is Six Sigma Define Face.